Welcome to Ancient Edge, where we uncover the forgotten genius of civilizations that built empires to last. Today we're standing in the shadow of structures that have defied the ravages of time for 2 millennia, and we're asking a question that should make every modern architect pause. How did the Romans create buildings that could resist the fury of flames, using nothing more than minerals, chemistry, and ingenuity that would seem almost primitive by today's standards? The answer lies not in complex synthetic compounds or advanced polymers, but in a sophisticated understanding of materials that we've largely abandoned in our race toward efficiency and profit. This is the story of Roman fireproofing, a tale of urban catastrophe, chemical innovation, and architectural wisdom that modern construction has left smoldering in the ashes of history. To understand why Romans became masters of fireproofing, you must first picture their cities as tinderboxes waiting for a spark. Ancient Rome was a densely packed metropolis, where multi-story apartment buildings called insulae rose 5 or 6 floors high, their wooden frameworks packed so tightly together that neighbors could literally reach across alleyways to shake hands. These structures housed Rome's teeming masses, often 1 million souls crammed into a city where open flames illuminated every room, braziers heated every corner, and cooking fires burned in countless kitchens throughout the day and night. The combination proved catastrophic again and again. The Great Fire of 64 AD under Emperor Nero stands as the most infamous conflagration, a blaze that raged for 6 days and 7 nights, consuming 10 of Rome's 14 districts and leaving thousands homeless. Ancient historians describe flames leaping from building to building with such ferocity that entire neighborhoods vanished in hours. But this wasn't an isolated incident. Rome burned repeatedly throughout its history, each disaster teaching its builders harsh lessons about the price of using combustible materials without protection. The Romans understood that fire wasn't merely a possibility but an inevitability, and this recognition drove them to develop methods that would make their empire's structures resist what had destroyed them so many times before. Their solution would involve chemistry that modern science has validated, but modern construction has largely ignored. The cornerstone of Roman fireproofing was a mineral that ancient miners extracted from volcanic regions and chemical works throughout the Mediterranean world alum. This hydrated double sulfate of aluminum and potassium possessed properties that the Romans discovered through observation and refined through generations of application. When wood was saturated in concentrated alum solutions, something remarkable occurred at the molecular level. The alum penetrated the cellular structure of the timber, and when exposed to flame, it would decompose and release water vapor and sulfur dioxide, creating a protective barrier that significantly reduced the wood's combustibility. The material wouldn't become completely fireproof, but it would resist ignition long enough to prevent the rapid spread that turned individual fires into city-destroying infernos. Pliny the Elder, that tireless chronicler of Roman knowledge, recorded the effectiveness of this treatment in his Natural History, and archaeological evidence supports his claims. During the siege of Piraeus in 86 BC, Roman forces bombarded the Greek port with flaming arrows, an ancient incendiary weapon designed to set wooden structures ablaze. Contemporary accounts noted with frustration that the roofs treated with alum refused to catch fire, denying the attackers their intended devastation. This wasn't folklore or exaggeration. Modern chemical analysis confirms that alum functions as an effective inorganic fire retardant, working through principles that remain valid in contemporary applications for paper and cloth fireproofing. The Romans had discovered through empirical observation rather than theoretical chemistry, a treatment that science would later validate. Now, the popular narrative often mentions vinegar and urine as Roman fireproofing agents, but historical accuracy demands clarification. These substances were indeed ubiquitous in Roman industry and daily life, but their role in fireproofing has been misunderstood or exaggerated by modern interpreters seeking sensational stories. Urine was collected in public vessels throughout Roman cities, not for construction purposes, but because the ammonia that developed in stale urine made it invaluable to the textile industry for cleaning and softening wool. Vinegar, that acidic staple of Roman cuisine, found its way into cooking and various industrial applications, but not as a standalone fireproofing treatment for construction materials. The confusion likely stems from our knowledge that these substances were commonly used by Romans, leading to assumptions about their application that historical sources don't actually support for fireproofing specifically. The true genius of Roman fire resistance extended far beyond treating individual materials. The Romans developed opus cementitium, their revolutionary concrete, which became the backbone of imperial construction and possessed inherent fire-resistant properties that modern materials struggle to match in certain applications. This concrete consisted of volcanic ash, lime and aggregate, creating a non-combustible, inorganic matrix that could withstand intense heat without structural failure. When flames engulfed a Roman concrete structure, the material's low thermal conductivity prevented rapid heat transfer, giving occupants precious time to escape and firefighters opportunities to contain the blaze before collapse became inevitable. Equally important was the Romans' strategic deployment of brick and stone. Kiln-fired clay bricks and blocks of travertine or volcanic tuff formed walls and structural elements that simply refused to burn. These materials retained their integrity even under prolonged exposure to extreme temperatures, a characteristic that proved invaluable in the aftermath of fires when assessment teams needed to determine which structures could be salvaged. The Romans also pioneered urban planning concepts that modern fire safety engineers would recognize immediately. Fire breaks created by wide streets, open courtyards within large building complexes that prevented fire from jumping between wings, and building codes that mandated certain construction standards after major conflagrations. This multi-layered approach, combining treated wood, non-combustible structural materials and thoughtful architectural design, created a comprehensive fire safety system that didn't rely on any single solution but instead built redundancy into the very fabric of Roman construction. Walk through any modern residential development or commercial district, and you'll encounter buildings constructed with materials chosen primarily for their cost-effectiveness, ease of installation, and speed of construction rather than their long-term fire resistance. Modern timber framing typically receives chemical treatments that offer fire resistance, but these synthetic compounds often provide protection measured in minutes rather than the hours or days that might prevent total loss. Gypsum drywall, that ubiquitous interior surface, does offer some fire resistance through the water contained in its crystal structure, but once that protection is exhausted, flames spread with devastating speed through the combustible materials beneath. The economic realities of contemporary construction drive these choices in ways the Romans never had to consider. Modern builders operate in markets where speed translates directly to profit, where standardized materials allow for rapid assembly, and where building codes set minimum standards that prioritize initial cost over lifecycle performance. A Roman builder working with alum-treated wood and volcanic concrete wasn't racing against construction loans or investor timelines. They built with materials locally available and techniques refined over generations, accepting longer construction periods in exchange for structures designed to endure. We've traded that longevity for efficiency, and while our buildings may meet code requirements, they often lack the inherent resilience that characterized Roman construction. As we stand here in January 2026, facing increasing concerns about sustainability, material sourcing, and the environmental impact of construction, the Roman approach to fireproofing offers more than just historical curiosity. It actually presents a challenge to our assumptions about progress and technological advancement. Could modern builders incorporate alum treatments for structural timber in residential construction, especially in fire-prone regions where wildfires threaten communities every year? Well, the answer is technically yes, though economic and regulatory hurdles make such adoption pretty unlikely without significant shifts in building codes or market demands. Heritage restoration projects have already shown that these traditional methods work, that they can be implemented safely, and that they produce results which synthetic alternatives sometimes struggle to match in specific applications. The broader lesson here extends beyond fireproofing to our entire philosophy of construction. The Romans, you see, built with an eye towards centuries, using materials that their environment provided and that they understood through generations of observation and refinement. We, on the other hand, tend to build for decades, using materials engineered for specific performance metrics, but often lacking the robust passive resistance that natural materials can provide. There's genuine wisdom in revisiting these ancient techniques, not to abandon modern innovation, but to integrate the best of both approaches. A building that combines the fire resistance of mineral-treated wood, the durability of properly formulated concrete, and the active protection of modern sprinkler systems would represent not a rejection of progress, but a synthesis of ancient wisdom and contemporary engineering. The Roman approach to fireproofing reminds us that innovation doesn't always mean inventing something new. Sometimes it means remembering what worked, understanding why it worked, and having the courage to challenge assumptions about what really constitutes progress. Those alum-treated beams that resisted flaming arrows in 86 BC weren't primitive or inferior. They were the product of sophisticated empirical chemistry, and they functioned effectively for purposes that modern materials, despite all our technological advancement, sometimes fail to achieve with the same elegance and sustainability. As we continue building our world, perhaps it's time to look backward before moving forward, to ask whether the ancient builders who created structures still standing after 2,000 years might have understood something about permanence and resilience that our era of planned obsolescence has, well, forgotten. If this journey into Roman ingenuity has sparked your curiosity, subscribe to Ancient Edge, where we continue excavating the hidden knowledge of civilizations that built to last. Share this video with anyone who believes the past has nothing left to teach us, and join us as we explore the forgotten technologies that shaped human survival. The ancients left us blueprints written in stone, concrete, and yes, even in minerals dissolved in water to protect wood from flame. All we have to do is learn to read them again.